Today's video is purely for educational purposes. Using large language models to predict the price of Bitcoin will probably not work out in winning trades in its current state. This is not investment advice, this is simply for educational programming purposes and fun. Now we're embarking on an exciting journey in programming by integrating AI capabilities into our projects. To achieve this, I'll be using several essential libraries that will allow us to perform various tasks. Let's start with the pandas library, which is a must-have for data manipulation and analysis. It's like having Swiss Army knife skills but for handling datasets. Next up we have NumberPy, or NP. Think of this as our go-to assistant when it comes down to crunching numbers quickly, performing calculations efficiently, or even creating complex mathematical models. It's the math wizard who helps us with all sorts of number games. Then there's matplotlib and its pyplot module, aliased here as PLT, a fantastic tool for visualizing data. Imagine transforming sales data from your retail company into visually appealing charts and graphs that highlight trends or patterns, without saying a word. Now, let me introduce you to requests. This library will be our scout when we need information from the web or APIs. Just give it an address and it'll fetch us anything available online. Finally, and most excitingly, there's Ollama. Think of this as our AI sidekick that can help add intelligence into what we build with pandas, NumberPy. Specifically, Ollama brings predictive modeling capabilities to Python programming, allowing us to forecast future outcomes or classify complex data sets. It opens up a world where Python programming is not only about data processing but also predictive modeling. Together these libraries will give us the tools to harness the power of big data and machine learning in exciting ways. Now we're going to work on a function that will allow us to fetch historical BTC price data from the CoinGecko API. This function, called fetch_BTC_price_data, takes no arguments but returns a pandas data frame containing date and corresponding Bitcoin price. The first step inside this function is defining some variables. A URL for the CoinGecko API which we'll use to fetch market chart data specifically for Bitcoin. We also set a few parameters that will be passed along with our GET request, the currency in which we want historical data, US dollars, represented by versus_currency, the number of days worth of data to retrieve, days, and the frequency interval at which the data is requested, interval. With these defined, let's make a GET request using requests.get with our parameters. If successful, the response will be stored in response. The next step involves checking if our API call was successful. If so, status code 200, we proceed to process this information by creating a pandas data frame from it. We split each line of the response text into two parts, date and price, and then use these as column headers for new rows in our data frame. In cases where things might not go according to plan, our function also implements basic error handling. If status code is anything other than 200, we print an appropriate message indicating that data retrieval was unsuccessful. In this case, we return none. Now we're going to work on this function, get_insights, which is used to generate some valuable insights using the Ollama AI. Essentially, what this function does is it sends a request to the Ollama model, passing in some historical data and asking for 15 price predictions based on that data. The function takes one argument, data, which I assume is a pandas data frame containing historical Bitcoin prices. The function then attempts to send a chat message to the Ollama model, providing it with some context about what kind of insights we're looking for, in this case, 15 future price predictions based on the given data. The response from the Ollama model is expected to be a list of 15 predicted prices. If everything goes smoothly, the function returns that list as its result. However, if anything goes wrong during the process, perhaps there's an error connecting to the Ollama API or something, the function will catch that exception, print out an error message, and return none instead. Now we're going to work on the main code. This is where everything comes together. We start by checking if this script is being run directly, rather than being imported as a module. If it's the former, then we execute the code inside this block. First, we fetch some Bitcoin price data using the fetch_BTC_price_data function. Then, we check if that data is not none. If it's not none, we proceed to get some insights from that data using the get_insights function. Again, we check if those insights are not none. If they're not none, we enter this block of code. Here, we generate a range of future dates starting from the maximum date in our historical data plus 1 day, up to the number of predictions we have. We then ensure that the length of these future dates matches the number of predictions. If everything checks out, we visualize and save those predictions using matplotlib. We plot both our historical data and our predicted prices, add a title and labels to the axes, and finally save the plot as an image.